Jade. Welcome for our next lesson via YouTube. I hope that you like this form of communication. Okay, short revision. Last lesson we were talking about second Newton's law of motion, mainly about second Newton's law. Oh, Newton's. Okay, so as a short revision, you have to know that force is equals mass times acceleration. So when object experiences a resultant force, then it accelerates, and acceleration can be found by using this simple equation. So you have to know resultant force acting on the object, and you have to divide this resultant force by mass. Okay, resultant force acting on the object divided by mass of the object gives acceleration. Okay, we did a few simple examples. Today I'm going to present how to solve a little bit more advanced problems related with objects which are connected by, let's say, a string. Okay, but at the very beginning, one more example with second Newton's law of motion, something similar to your homework. Okay, I want to say that only 3 people sent me solution for the homework, so remember, this is normal lesson. You must do your homeworks and send me a solution via email or via e-register. Okay, so let's imagine that you have an object, a car of unknown mass, okay, which experiences 2 forces, engine, okay, and a resistive force. It can be friction, a resistance. In general, it's resistive force. Okay, and let's imagine that engine of this car produces 5,000 newtons of force, and the resistive force is 1,000 of newtons. And we know that car accelerates because the resultant force acts on the car. Engine produces bigger force than resistive force, so car must accelerate in the direction of larger force, so to the right. And we know in this example that car accelerates with acceleration let's say 4 meters per second squared, and task is find mass of the car. Okay, so copy this. You have, let's say, 3-4 minutes to find a solution, to find answer for this problem. So please stop the movie for 4-5 minutes, solve it, and then tour it again. Okay, I hope that you finish this. So step by step, how to solve it. First of all, you have to find the resultant force. Remember that the resultant force is sum of all forces acting on the object. In this case, object experiences 2 forces. Engine, which is directed to the right, and resistive force like a resistance or friction, and this force is directed to the left. So we have to subtract because direction is opposite. Remember, force is a vector. So engine 5,000 newtons minus resistive force 1,000 of newtons results in 4,000 of newtons of force. So this is the value of overall resultant net force acting on the object, and we know that this force is directed to the right because engine is bigger, force from the engine is bigger than resistive force. Okay, the question is about mass. If force is equal mass times acceleration, for people who don't know maths, you can write this in the form of formula triangle, then mass is force divided by acceleration. You found the force, acceleration is given, then you can calculate mass of the car. Remember, we've used standard units, so answer must be expressed in standard units. Standard unit of mass is kilogram. So what is the answer? The answer is mass of the car is 1,000 of kilograms. Okay, I hope that you did this correctly. It was not a difficult problem. It was just revision of our last lesson, of our last meeting. Okay. So today's topic is the same, second Newton's law of motion examples. So please note in your notebooks, topic, second Newton's law, examples. Okay, and today I'm going to focus on problems related with tension objects connected by the string. So example 1, do with me, then example 2 you will try to solve working alone, and next example you have to do it alone. So let's look. Let's imagine that you have a surface, a frictionless surface, no friction, we are not interested in friction today. Okay? And on this surface you have two objects, a bigger one and a smaller one, which are connected by a string. What is important assumption? This string is unextensible, so it doesn't take any energy from the system. And let's imagine that system of these two objects experiences a force. Okay, so there is something like my hand which pulls these two objects by a force of, let's say, 50 newtons. Okay, and we know masses of the objects. Bigger has a mass of 6 kilograms and smaller has a mass of 4 kilograms. Okay, and the question is, what is a tension of this string? Let's look. This string tries to be extended. Okay, this string is connected to the huge mass, and the mass experiences a force of tension of the string. Is it clear? So the question is, what is a tension, force of tension? I'm going to use Ft of this string. Okay, so step by step. Listen carefully. Second example, you will try to do working alone. Okay, so let's look. First of all, we know overall force acting on the system, and we know mass of the system. This force, this 50 newtons, acts on two masses, 6 kilograms, I'm going to use symbol M1, and 4 kilograms, I'm going to use symbol of M2. So overall force acting is 50 newtons, and the mass of the system is sum of masses of these two, let's say, boxes, objects, so sum of 6 and 4, which is 10 kilograms. Okay, so what can you calculate? We know overall mass, we know overall force, so we can calculate acceleration of the system. Acceleration, by using second Newton's law of motion, is the ratio between force, which is 50, and mass, which is 10, so 5 meters per second squared. Okay? These two objects are connected, which means that mass 1 travels with acceleration of 5 meters per second squared, 5 meters per second squared, and mass 2, which is connected to mass 1, also travels with acceleration of 5 meters per second squared. Again, these two objects are connected together. Is it clear? So now let's focus on mass m1. We know that m1 is equal to 6 kilograms, and we know that m1 travels with acceleration of 5 meters per second squared, and we know that m1 experiences only a one force, a tension. So we have something like this. Object of mass, which is 6 kilograms, experiencing force of tension, and due to this force of tension, it travels with acceleration of 5 meters per second squared. So we know acceleration, we know mass, we can calculate force, because force is mass times acceleration. We are looking which force acts on mass number 1, so this is tension. So we have to multiply m1 times acceleration, which is equal to 5. Mass 1 is 6, acceleration is 5, so force experienced by mass m1 is 30 newtons, so tension is 30 newtons. And this is the end of the exercise. Stop movie for a moment, copy this example to your notebooks, and when you will be ready, please turn it on again, and then we will do together second example. Okay, so let's do second example. Again, very similar. Okay? Let's imagine the same situation, so you don't need to imagine. We have again two objects, M1 of 2 kilograms and M2 of 4 kilograms, connected by an extensible string. And let's imagine that the overall force acting on both is 20 newtons. And again, the question is, what is a tension of the string, or other words, what is a force which pulls mass M1 to the right? Okay, and the same problem as previously, so please copy this to your notebook. Stop movie for a moment when you will copy. Let's do with me. Okay, first of all, you have to calculate acceleration of the system. Acceleration is F over overall mass. Force is 20. Mass is 2 plus 4, so in this case it's 6. So acceleration is 3 and 2/3 of meters per second squared. Now let's focus on mass M1. M1 is equal to 2 kilograms and experiences unknown force, force of tension, and due to this force it travels with acceleration of 3 and 2/3 meters per second squared. So how to find force of tension? Force of tension is product of mass on which it acts, so M1, and acceleration which is given, which was calculated by you. So this is 2 times 3 and 2 over 3, which is 6, 7 and 1/3 of newtons. Ta-da! If you have a result like this, then very, very, very good. Okay? So one more example, or homework. No, one more example. Okay, so similar situation, two objects, M1, which is 5 kilograms, connected with M2, which is 5 kilograms. Okay, and now a little bit different, because we don't know overall force, but tension is given. So let's imagine that tension in this case is, let's say, 10 newtons, and the question is about overall force. So now let's copy this, stop movie for 5 minutes, try to solve it working alone. After 5 minutes, turn it on, it will be solution on the screen. Okay, so first of all, let's focus on mass M1. Okay, M1 is equal to 5 kilograms, and we know that M1 experiences force of tension, which is equal to 10 newtons. What can you calculate? You can calculate acceleration. Acceleration is force, in this case force of tension, divided by mass, in this case M1. So this is 10 divided by 5, which is equal to 2 meters per second squared. Okay, these two objects, M1 and M2, are connected together. So now let's focus on connection of M1 and M2. M1 of 5 kilograms connected with M2 of 5 kilograms, and we don't know what is overall force acting on the system, but we know that this system, these two masses connected together, accelerate with acceleration of 2 meters per second squared. So what is a force? Force is mass times acceleration. Overall mass times overall acceleration is 10. Mass is 10 because M1 plus M2 is 5 plus 5, so 10 kilograms. So 10 times acceleration 2, it was calculated here. M1 is connected with M2, so both objects accelerate with acceleration of 2. 10 times 2 gives 20 newtons, so overall force acting on the system is 20 newtons. I hope you have the same solution. If not, please stop movie, copy this, and learn, of course. Okay, and now your homework. Homework will be a little bit more complicated because I'm going to give you 3 masses connected by strings, 2 strings. Mass 1, which is, let's say, 2 kilograms, connected with mass 2, which is, let's say, 3 kilograms, connected with mass 3, which is, let's say, 5 kilograms. Okay, and these 3 masses connected together experience a force of, let's say, 20 newtons. Yeah, and your task is to find 2 tensions. Tension of the first string, so basically force, let's name this Ft1, acting on mass m1, and tension of the second string, let's name this Ft2, force acting on mass m2, but remember that mass m2 is also connected with mass m1. So again, you have 3 masses connected by 2 strings. Overall force acting is 20 newtons. Okay? And these 20 newtons is the force acting on 3 masses. Mass 1 is 2 kilograms, mass 2 is 3 kilograms, mass 3 is 5 kilograms, and your task is to find Ft1 and Ft2. Good luck with your homework. See you on next video lesson. Thank you for your comments. I hope that this form of communication is not bad. If you have any suggestions, please write to me by email or write as a comment on YouTube movie. Okay, see you next time. Bye.